Welcome to qnawire.
Okay, in this problem we have CO2 gas, carbon dioxide. We have 8.5 moles of it. The gas is at 300 Kelvin and occupies a volume of 0.22 meters cubed. We're asked to find the pressure using the ideal gas law and the van der Waals equation. We're going to compare the results. These are two competing equations of state. One I suspect will be more accurate is the van der Waals equation, being a little bit more complicated. Take some of the ideal assumptions out of the ideal gas law. But we'll see how close they are for this particular case. So to start, we can look at the ideal gas law, PV equals nRT, and we can simply reorganize for P, which is nRT over V, of course. Our value, we have 8.5 moles, the gas constant is 8.314, and the temperature is 300 K, occupies a volume of 0.22 meters cubed. Number crunch that, you get 9.64 times 10 to the 4 Pascal, so about an atmosphere. And we can move on to the van der Waals equation. So here's the van der Waals equation. We can simplify it a tiny bit to get it into a slightly different form. We could have nRT over V minus NB minus AN squared over V squared. And the constants we have for B, value of 4.5, 10 to the negative 5. The units are meters cubed over moles, if you're curious. And for A, 0.36 Newton meters to the 4 over mole squared. I'm just going to include the values, not the units. If we plug all of this in and compute a number, we would end up with about 9.6 times 10 to the 4 Pascal. So you can see almost immediately these numbers are quite close to each other. If we took a percent difference, we would see that it was about 0.39%. So these numbers are quite close to each other. So in this case, the two equations of state do not diverge very much.